Stanford University.
All right, guys, welcome to CS 193P Lecture 18. We're kind of starting to wind down here, just 2 lectures left. So, I'm sure everyone's already done with their final projects by now, probably, right? Yeah, well, all right. So today we've got a little bit of a grab bag. It's a bit of a mix of things. We're going to start out talking about unit testing. Arguably, we should have started out talking about this at the beginning because you'll have wanted to use it all along. But we're getting to it now, so better late than never. Then we're going to kind of get into some. This fun with Objective-C is basically what not to do and how to do it. So we'll talk about that for a little bit. And some of that actually gets into how the unit testing stuff is implemented, and it's actually really interesting stuff and gets into some of the meat of the way that Objective-C works and the things that make it so dynamic and cool. So that's actually a lot of fun. And then maybe a little bit less exciting up front, but definitely no less important than the other things. We'll talk about localization. So the App Store is available in countries all around the world now, and you can write your app and deploy it to all these different countries. You want everyone who downloads it to be able to read it and understand what it is that your app says. So we'll talk about how you can localize your app into multiple languages and get your nibs and strings to lay out correctly and show the correct words and stuff that people can actually understand. And we'll end up with some. This is the real grab bag part, I guess. We'll talk about some questions that we've gotten through emails and basically frequently asked questions kind of deal is what we'll finish with. All right, so let's start out with unit testing. Some of you may have heard this. Anyone's done unit testing before? Have seen it in other classes? Yeah, a little bit? All right, well, so there's a couple of other unit testing frameworks for other languages. We have one for Objective-C as well, and it's actually part of the iPhone SDK. But before we get too much into that, I guess it's important to know what exactly a unit test is. So unit test, the idea here is that you want to test specific areas of functionality in your code. You want to make sure that different bits of code are behaving the way that you expect them to behave, and that they continue to behave that way as you continue developing over time. You basically want your unit test to be pretty self-contained. Everything that they're testing should be functionality that can basically be wrapped up within the test itself and obviously the code that it's testing. You want to avoid external dependencies like networks, servers, and things that may come and go and not necessarily be available. And you want to run them frequently. The real idea here is that we're testing the functionality of the code that we're writing to make sure that it continues to work over time. So to make sure that that really provides us some kind of benefit, we want to run the unit tests often so that we'll notice failures up front and really quickly before they get checked in and become part of our code and hard to track down later on. So testing is kind of an interesting area, and traditionally testing has been done in a lot of companies as sort of a separate organization or some other guy who does the testing, and he'll write some test code and maybe write some test cases, and maybe he'll have some user interface testing framework that plays with your device using some sort of simulated input. And that's super useful and very interesting, and it's a great way to do testing. But this is kind of a different side. This is before that would even happen. The idea with unit testing is that you write the tests. The guy who's writing the code is also the person who's writing the tests. You really want to make sure that they sort of encompass the specific behaviors that your code is trying to actually achieve. The idea is that they're actually quite tied to the implementation and functionality. So ideally, they're written along with new code. As you're writing code, you want to write a test that tests that code so that as you move forward and change that code, it's working the way that you expect it to be. And a particularly interesting method of doing this with unit testing is to kind of flip the whole problem on its head and actually write the tests before you even write the code. So you can kind of start out writing unit tests that test the behavior that you intend to implement in your classes. So this may seem a little bit odd, and I've gone back and forth on how I feel about this throughout my career, and sometimes I find it much more useful than others. I think you'll find it depends on the project you're working on and the specific case. But I definitely do believe that there are many instances where it's a very interesting way to do things and definitely really useful. So basically just sort of the idea is you frame out your code that you want to write. So you define some method that you want to implement. And then you write a test case that tests that method does what it is that you want it to do. So you write the test case first, and then you write the code. So you're basically writing the code until such time as the test case passes. yeah, you've basically tested the thing before you've written it, so that once you're done, you know you're done because the test case works. That's where it gets a little hairy, because obviously test cases don't necessarily test every single aspect of the behavior of your application. But it can be very useful for that. And then you basically do the same thing over again. And you've got a new area of functionality you want to implement, so you frame it out, write the test cases, and then implement the functionality. All right, so you've got all these things written, but how are you going to run them? I mentioned that you actually would want to be running them fairly often throughout your development. And if you kind of leave it up to, I'll run this like once a week or once every day or something, it quickly becomes something that you very easily put off and say, I'll do it later. And then 2 years later, after you've shipped 3 versions of your product, you're like, I should run those test cases again, and nothing works. So you want to avoid that. So the best way to do this is to actually have it be part of your build process. If part of building your application and your iterative development is actually running the test cases every time you build, and you don't have to do anything extra to make that happen, then they're just going to run, and you won't try and skip them. You'll just do it. And when you see a failure, you'll find it right away, because as you're changing your code, you're noticing the failures in your test cases. So that's a pretty common way to do it. So you can kind of think of it as another step beyond the compiler. The compiler is taking your code and running over it and turning it into machine instructions. But part of what it does for you is verify that your syntax is correct, right? If you've forgotten a semicolon somewhere, it's going to throw up an error and tell you that you've done this. You can kind of look at unit tests being run after that as a way of testing the semantics of your program. So the compiler is checking your syntax, but then once your syntax is all correct and everything's building and running, your unit tests are testing the semantics to make sure that the behavior that you think that your functions have is the behavior that they can continue to have as you change other things in the future. All right, so we've kind of covered a little bit of why you might want to do this, but let's enumerate a few reasons here. So first of all, the goal would obviously be fewer bugs. This is pretty much the goal with any testing. You want to catch bugs and eliminate them. The nice thing about unit testing is that you'll catch them earlier. I mean, if you've done a good job of writing your unit tests and you're covering a lot of the functionality of your code, you're going to notice pretty quickly if you've broken something, because one of your unit tests will fail. So it kind of gives you a couple of things from that. The first is that you've got a higher level of confidence that you've actually are going to ship a quality product. You're pretty confident that the behavior you wrote at the beginning is still the behavior 2 years later after you've changed all your source files and rewritten everything from scratch 4 times. It also gives you that confidence to rewrite stuff. I've found some of the code that I feel by far most confident doing large-scale changes on is code that I have significant amounts of tests for. One example of that, and it's an odd example because it doesn't actually use the framework that we're talking about, but I've done a lot of work on phone number formatting and matching on the iPhone, and it's one of actually the areas that I feel most comfortable changing code, because there's just a huge test suite of phone number validation to make sure that we're continue to format and match phone numbers the same way we always have in the past. So as we add support for new countries or change the way we do things, if something breaks, it's immediately apparent that a phone number we used to format correctly is no longer formatting correctly, or we're not matching this thing in the address book that we used to. So it really gives you a lot of confidence to change things and play around and come up with new ideas for how things should work without worrying quite so much about breaking things that you've already done in the past. So yeah, it also helps you to find the bugs early. They're a lot easier to fix when you find them before you've checked in the code that breaks it. If you check in a bunch of code and it causes some bugs and breaks some things and you don't notice for 2 months, 2 months later, when you find those bugs and go to try and fix them, you've probably got 9 other check-ins since then that are relying on the broken behavior that you checked in before. So now when you go and fix it, now you've got other things that broke that you checked since, and it becomes this huge mess of just entangled changes that are all relying on each other. If you can catch it earlier, it's much cheaper to fix and a lot easier, and you won't end up with this nightmare 2 days before you ship where everything is broken and nothing works. Not that that's ever happened, because it never happens. It also helps you, avoid regressions, as we said. As you're changing things, you'll notice if something broke, so you won't check in the thing that regressed functionality that you had correct originally. And it also actually helps you to document your code. A lot of the documentation that Apple supplies is obviously written by the documentation team, and there's also a lot of comments in the header files that describe how things should work. But the danger with both of those things is that they very quickly can become out of sync with the actual behavior, if people aren't actually maintaining them. Documentation specifically it's written by someone else probably. It's not written by the engineer. So if the code changes, the person who wrote the docs may not even know. Comments in header files are also useful, or even in the source file. But I can't tell you how many times I've come across a comment that is just clearly wrong. I mean, it's documenting code that's not even there anymore. And at some point, that's just totally, well, obviously, it's always totally useless to have comments that mean nothing. But the unit tests are a great way to document things because not only do they, in words describe how things should work, they actually in code describe how things should work. Because your test case is testing some functionality. So if you've written a particular function and you know how it was intended to be used, a great way to express that to someone else who comes along later is for them to actually see it being used. And a test case is a perfect way to show that because not only is it verifying that it's doing what was expected, but in your test case, you're actually including basically documentation of how the function is supposed to be used, what its return value should be, what should be passed in, what its side effects should be, if it should be throwing exceptions. The more descriptive your unit tests are, the more self-documenting basically your entire project can be. And it also helps to encourage good design. I mentioned that unit tests should be pretty self-contained. One of the side effects of that is it kind of discourages you from having just massively entangled amounts of code where all of your project knows about every other file in your project and you've got global variables everywhere. Because if you try and do that with a unit test, it's going to be impossible to write a unit test that tests just one piece of functionality. Your whole application would be involved. So it kind of helps to push you towards encapsulating things and having smaller bits of functionality that are independent of the rest of your application that can be tested independently and then used independently and reused in different parts of your code. So it's pretty nice for helping that. So I mentioned that some of these other languages have some unit testing frameworks. What have you guys used before? I mean, are there classes that have introduced this? Or?
JUnit is what we...
JUnit? OK, cool. So I guess, what's that? So this is probably going to look a little bit similar then if you've seen that kind of stuff before. JUnit, NUnit, PyUnit, those are some other examples of similar unit testing frameworks for other languages. The one that we have for Objective-C is called OCUnit. One thing that's a little odd about it is that though the name of it is OCUnit, when you look for the headers and actually try and find it while you're working with it, all the headers are named Send Testing Framework, which I don't actually know the history of that or why that is that way. But anyway, it's OCUnit. Just look for Send Testing Kit. Anyway, it ships with the Mac OS X developer tools, so you don't have to go out and try and find it. It's actually, you've got it already. It's on your system. And it's integrated with Xcode. And since the last time that we talked about this, actually, in a couple of years ago, it's actually been more tightly integrated with Xcode than it used to be. You can actually create a new target in Xcode that is a unit testing bundle. And you can basically create that, and it sets everything up for you, and you can start writing your test cases. So it's pretty convenient, and it's been included with the SDK since iPhone OS 2.2. So it's been around for a while. A lot of people are using it, and it works pretty well. So yeah, Send Test Case is the basic building block of all your testing on top of OCUnit or Send Testing. Yeah, it basically automatically is going to run any methods that start with the word test. And this is the part where we're going to get into a little later, some of the crazy what to do or what not to do and how to do it kind of deal. But basically, it looks through your entire subclass of Send Test Case, finds all the methods that start with test, and runs each one at a time. And all your tests are then one in each one of these methods starting with test. It has a bunch of macros that it defines for asserting that particular conditions should be true or false. So you can assert, in this case, that some object is not nil. And your test case will actually generate an error then if for some reason you get to that point and some object is nil, and it'll write out whatever message you said here. In this case, some object was nil. There's a ton of these different assert macros. You can open up send testcase.h and see the whole list of them. But there's all kinds of things from verifying that an object's nil, that an object's not nil, that two objects are equivalent, that they're not equivalent, that a particular exception has been thrown, that no exception has been thrown. You can basically document using all these assert macros, exactly what is supposed to happen as a result of different calls and at different points in the execution of the test. And there's also, then you define setup and teardown methods These are optional. You don't necessarily have to use them, but they basically are, they're called before and after OC unit executes every single one of the test methods that you've defined. So if you had, for example, you needed to always create this one object that you were going to use in all your test cases, you could create it in setup and destroy it in teardown, and then you'd know that every time that one of your test cases got called, you'd have a brand new, just allocated copy of this object, and you wouldn't have to duplicate that code in each test. So that's pretty convenient if you're writing a bunch of tests to verify your one particular area of functionality, but you're verifying all kinds of different functionality on one class, and you always want a new copy of that class for every test case. Let's get right into it, actually. It's pretty easy. Basically, you've seen pretty much this whole thing before. There's nothing new here. You're going to import the header. It's from sendtestingkit/sendtestingkit.h. We're going to forward declare the class foo. You could also pound import your header, but generally, since in our header for the test case, we don't actually need to use, we're not calling methods on it. We can just forward declare it. And then we're going to declare an ivar of type foo called foo, just to be confusing. We'll call these things the foo tests, and they're going to inherit from send test case. So the header's pretty straightforward. The implementation is actually no more complicated, really. We're basically implement the setup and teardown methods that we just talked about, and we'll alloc init one of these foo objects in the setup. So every new test case that we run will have a brand new foo object, and we'll release it in teardown so that it gets cleaned up afterwards, and we're not leaking memory all over the place while trying to run our test cases. And then you just start implementing methods, and as long as they start with test, they're all going to get called one after the other with the start and or setup and teardown called before and after each one. So in the first case here, we'll call test create foo, and in this one, we're just verifying that that setup method actually succeeded in creating the object foo. Basically, we're verifying that our alloc init method is in fact doing an alloc init and returning self, and that we actually can get an object. So probably not the most interesting test case, but it's verifying that something happened. And if for some reason that fails, we know we've really done something wrong and something's gone terribly awry. So that one's pretty straightforward. Then the second one is just testing a setter. So we'll test that. Basically, we're going to get a new object bar and assign that new object to the bar property on our foo object. And then we'll use stassert equal objects to verify that that set has actually happened. This is not just going to do pointer equality. It'll actually run the isEqual method on these objects to verify that they're the same. So even if your setter actually made a copy of the object, that's still OK as long as the copy of the object is still isEqual to the original. This will pass. So this can catch cases where maybe you've implemented a setter and you've got some early return in it or something and forgot to assign it to your ivar. It'll get caught right there.
What if you want to compare it to like a primitive, like an int or something?
So the question is, what if you want to compare two primitives? I think there's also macros for that. I don't think they're the same as this, but we can look at it in just a second. But I'm sure there's macros for doing primitive comparison as well. So that's kind of testing that things have happened. But you may also want to test that things haven't happened. For example, that you haven't thrown some exception. So in this case, we're going to test the access to an out-of-bounds value. This is a little bit odd because it kind of goes against the out-of-bounds behavior of NSRA, but just bear with me for a second. So we'll assume that we're going to have a method on foo called bar@index, and that you can pass whatever index you like. And let's assume that in this test case, we know that there should never be a bar object at index 99. So, and we'll define that the behavior of bar@index when an object doesn't exist is that it returns nil. This is the odd part because that's not the behavior for NSRA, but let's assume for this case that it is. So in this case, we're going to assert that foo bar@index 99 actually does return nil, and we'll get an error back, and the test case will fail in the case where, for some reason, we actually get an object. All right, so it's probably easier to see this than to talk about it. So let's take a look at what all this looks like. So I've started out actually with a project here that's built a lot of this stuff already. We've got our app delegate, and that's pretty much the same as you've seen everywhere else. There's really nothing special here. Application did finish launching, just makes our window visible, and our dealloc releases it. So we've got a person object defined already, and that person object is just a subclass of NSObject, and it has a single ivar called displayName, and a single property called displayName also, which just copies the assigned value into it. And person.m has this implemented. We're synthesizing displayName, so we don't actually need to write the methods. So there's really nothing else. The dealloc will just release it when we're done. Since it was copy, we actually have a retain count, so we have to release it. So really not too much code here. So let's think about what we might want to test there. So I've already set up a target here called the unit test target. If you were setting this up yourself, you would basically go to the project menu here and go new target. And one of the options for a target is a unit test bundle. So that's pretty much how you'd get started adding this to your own project. But I've already done that for this case. Since it's a separate target, there's something interesting here, which is when you're in your overview pop-up menu, and there's a couple other ways to get to this as well, but you can pick the active target at any given time. And by default, your active target, you've probably only ever had one, and it was your application target, which is going to build and run your application. Given that we now want to actually run these unit tests every time we build, we want to set our unit tests target to be the active target. But we also want to make sure that that rebuilds our entire application as well, so that we don't have to keep switching back and forth between these targets. We can just always keep unit test target as the active one, and still be able to do our normal build and run cycle of development. So the way that we've accomplished that then is that if we get info on that unit test target, one of its direct dependencies is set to the test my app target, which is our application target. So what that basically says is that anytime that we try and build the unit test target, before we can do that, we have to make sure that the test my app target is both built and up to date. So if any of the source files have been edited or changed, it'll build them first before it tries and runs the unit tests. All right, so we've got this set up now that we can build our unit tests and run them. There's not too much going on in them just yet. Let me get back to this here.
Can you do it in the reverse order and make the unit tests depend on, you know what I mean, like flip it?
So the question is, can you do it in the reverse order and make the unit test depend on the app? So the issue there is going to be that the new version of, like if you had frameworks built as part of your app, which I guess on iPhone isn't going to be a problem, but on Mac OS X would be, the new versions of the framework wouldn't have been built yet before running your. Oh well, I guess that's actually not even true.
Oh, you want your tests to run after your app has been rebuilt?
Yeah, but actually that, yeah, no, yeah, I don't think you could actually have it work the other way. I've never tried it, so I'm honestly not entirely sure. But if your app hasn't actually been rebuilt, I think you'll be basically testing the last version that you built, not the current version. Right. So our test, our person tests.h just has we're importing send testing kit.h, and we've got person tests inheriting from send test case. So we can just start out implementing a few test cases, and I've already got a couple here. They all start with the word test, so they'll be run automatically. This is probably different than what you've seen with some of the other some of the other unit test frameworks like JUnit. You probably, well, maybe not with JUnit, but with the C++ ones, you certainly would have to have defined which tests you wanted to run yourself. I'm not sure that the Java one probably can figure it out for you. So yeah, you don't have to specify in this case. So our test create person will basically just alloc init a person object and assert that it's non-nil. And our set display name is going to get a display name here. We'll just use a static string, alloc a new person object, and use the property access to assign that to the display name property. And then after we've done that, verify that that assignment has actually happened and that person.displayname is in fact equal to the display name that we just tried to set it to. So if we build now, everything's going to work because our code is already correct. There's no problems. So let's go introduce some problems. We've got the display name method here. Let's say we thought that maybe we need to implement our own accessor, or rather our own setter in this case. So we'll do void set display name and a string display name. Well, actually, what did I call that, Ivar? Display name. But let's say that I got distracted after I added that to my source code and I went and did something else, and then I just tried to build. We're going to find out right away that I just implemented an accessor that doesn't actually do any setting or actually have any effect at all. Because if we take a look here at, let's make this bigger, the results of our run unit tests, the first thing we're going to see is that Paul should be equal to null, which is kind of a weird way of expressing it. But it's basically saying that the first variable here should be equal to the second variable here and is not. And person.displayname is null, which is why we see null there. Because we're not actually assigning it to our Ivar. We could have had some other information passed along here. You forgot an assignment. And then that would actually show up there, along with the error. And that can actually be a format string, so you could include standard NSLog style format specifiers within that string, and then the additional parameters afterwards. So if we go ahead and, I lost my window here. So if we were to go back to our person object then, and then just add the assignment in there. I said it was a copy, and actually need to release that first. Then when we build, oops, no reason to run. But when we build, we no longer have the error, because now we've actually assigned the IVAR, so now our test case succeeds again. So it's a quick way to kind of catch that we've made what would otherwise have obviously been a pretty clear mistake, and it's a good way to catch even more complicated mistakes as well. So when does this make sense? Because, I mean, as I mentioned earlier, there are certainly cases where it doesn't. Well, basically, you want to try and consider what the return on investment for writing these test cases is going to be. What's the likelihood that you're going to break this code? What is the benefit you're going to get from writing the test case in the future? What is the future benefit you'll get versus the time you're going to have to invest now to actually write the code? And that's always a trade-off. It's kind of hard to say. We all go back and forth on that all the time, I guess. Sometimes, depending on even points in the release cycle. Earlier in release cycles, when there's a lot of time available and there's no release date pressures, or you really feel like you have to get stuff done and checked in and shipped, it's a lot easier to justify spending a little time writing the tests than maybe at the last minute. Although, honestly, at the last minute is probably the better time to be writing the tests, because you also are making changes, and you really want to make sure you're not breaking stuff then. But having written the tests at the front makes it a lot easier to make changes without being quite as concerned that you're breaking everything later on in the release cycle. So it's a cost-benefit thing, and you kind of have to weigh it for your particular situation as you go. But and also, some types of code are just difficult to test. A lot of this self-contained thing I was talking about is really hard to accomplish if you start talking about networking code or database code. You can often test a subset of the behavior, like verify that the results of your database fetch are processed correctly, but not necessarily do the actual database fetch. You could also, yeah.
Is it possible to test user interface code, stuff like view controllers and stuff?
So the question is it possible to test user interface code? It varies a bit based on your definition of test user interface code, I guess. You can certainly test view controllers type stuff, like view will appear and view did appear, and basically programmatically initiated and controlled things. Testing things that require user interaction is not really possible. I mean, you can't simulate a series of touches pinching your scroll view, so it's not really reasonable to write unit tests to verify that your touch manipulation code is doing the right thing, because you can't actually simulate the input that you would need to verify it.
I think there's some stuff in instruments, I don't know how fully in-depth it's implemented, that can drive some automated UI tapping. You can record some stuff. I'm not sure how well it works.
Interesting.
I mean, can't you just call the methods that the touches would end up calling anyway, and just simulate those in the test function?
Sure. So the question is, couldn't you just call the methods that the touch code would have called anyway? And absolutely. I guess that kind of gets towards the testing a subset of behavior. You can verify that the code that would have run as a result of the user pinching is working correctly, but you can't necessarily test that the code that checks to see that the user is pinching is working correctly. Although I guess Paul says that, I don't know too much about this on my own, but that instruments include some limited support for doing touch manipulation recording and playback. I've never used it. I certainly will look into it now, though. Right, so we've kind of covered this as a little bit of a rehash, but basically the idea is to keep your tests pretty short and pretty lightweight, and make them run pretty fast. And that's probably common sense, given what we've already said about wanting to run them with every build. If your tests take a super long time to execute, you're probably going to feel like you just want to turn them off and not run them when you're building. So if you keep them short and keep them fast and keep them light, you'll be more likely to leave them on and actually run them and catch your regressions. Test You also want to try and test individual methods, not necessarily full end-to-end behavior. This kind of goes along with what we were just talking about with testing a subset of your functionality. For example, you probably don't want a single test case that verifies that your game launches, plays through every single one of its 100 levels, and shows the final splash screen correctly. But having a bunch of smaller test cases that can verify that it's correctly creating your starship and correctly handling the fire lasers method, and that your final game did complete screen, works correctly. Individual small things like that are better served as individual test cases rather than one just huge monolithic test case that's going to take forever to execute and the whole thing fails, and that's not too useful. And when you find a new bug, actually, think about writing a test case to verify your bug, maybe even before you've actually written the fix. It's basically, actually before you've written the fix is a great time to do it, because you can write a test case that you're writing it specifically because you want it to fail for the bug that you're trying to fix right now, so that you know that when you fix the bug, your test case starts working. And one of the great benefits of that is you fix this bug that you just found. Now you can be pretty confident that in the future you've not broken that bug, reintroduced it with some new change, because you've got a test case that verifies that your fix for the bug actually fixed the bug, so you'll notice if you break it again. And as we mentioned, it kind of complements the other types of testing, sort of more user interaction testing and real-world usage and actual larger scale tests done by a more structured testing organization, I guess. So it's not necessarily a replacement for that, but it's a good complement to it. So how do these things work, right? We've seen that it can sort of figure out which methods we've written that start with test. It seems a little magical. Objective-C is incredibly dynamic and provides some really, really cool things that let you do things like this, where the runtime can actually tell you what the methods are that it knows about. One of the caveats here, and one of the reasons I started out hesitating a little bit when I said we were going to talk about this, is that this is kind of what not to do. We'll get into it a little more at the end. There's great use cases for this and some really cool things you can do with it, but use it with caution. There are a lot of dangers around this area as well. So it's pretty low level, and you can pretty easily end up making code that's incredibly hard to maintain and really easy to break if you use this the wrong way. So having said that, let's take a look at all the cool stuff we can do. So how does OC unit find all those methods, right? And what else can we do? So user include objc is the place where you're going to get started with all this stuff. Objc.h is basically the Objective-C header. It defines a whole bunch of stuff that the entire objc runtime uses. ID, nil. Capital nil is nil for a class. Lowercase nil is nil for an instance. They're both 0, so fun names. Capital bool, capital yes, capital no, all that stuff's defined in that header. Objc message.h defines a bunch of the low-level methods that are used for message sending. You may not have seen this yet, although you may have if you've been writing any code that's crashed, anytime this semester. Objc message send has probably shown up in a backtrace if you've sent a message to an object that you've already deallocated. It's basically when you write a square bracket and a message send syntax in your Objective-C source file, what the compiler ends up turning that into is a call to the objc message send function. And there's actually a couple of them. There's objc message send, there's objc message send fpret for messages that return floating points, floating point values, objc message send stret for methods that return structures. But objc message send is probably the most common one. It's used for anything that returns an integral value or a pointer or an object. Those are all defined in objc message.h. Objc runtime.h is probably the most interesting of all these in terms of crazy things you can do to the runtime. It basically lets you inspect and manipulate all sorts of different aspects of classes and protocols and methods. It can even let you do things like adding and replacing methods on classes at runtime. So while your code is running, you can actually add a new method to a class that you hadn't even defined on that class when you built it. And actually, that's how the categories on methods in objc work. you don't necessarily see this thing happening, but the runtime itself, when it's loading a new, so if it loads a framework that defines a category on a class that existed in your application, the runtime will actually dynamically insert these methods as part of the class when it loads that framework. All right, so let's take a look at some of the methods or functions you can use for this. This is probably one of the most interesting ones right off the bat. Class copy method list. Given a class and an output value where it's going to write out how many methods it copied, it will return you a malloc array of all the methods that that class defines. Once you've got those, you can then get things from them, like their selector. So method getName, given a method that we just got back from this function, will give us the selector used to call that method. Now, this is where we start to get into things a little bit that we glossed over earlier in the semester. We kind of talked about methods and talked about selectors, but we didn't really say too much about what their difference was. We kind of basically said you can consider them the same for all intents and purposes. That starts to not be true now once we start talking about this. So selector is going to be basically your abstract name that defines a way to call some method on your class. What that method is can be changed at runtime. And so they actually are two different things, and you can replace the method that is associated with a particular selector on a given class. So code that was compiled to call a particular selector may actually end up calling some different method at runtime if you've manually replaced it. Now this is where we really start to get into the how to do this and don't do it kind of deal. But so basically method get implementation is even one step beyond that, which is given a method, you can actually get an imp. And an imp is effectively a function pointer. This is the part that this basically would take all the dynamism out of all of the objc runtime if you called things through this. You could basically get the implementation for a method, and basically you can use it like a function pointer and actually call the implementation of a method without going through the selectors and the entire dispatch. Don't do that. That's almost never what you want. The cases where it's useful are, there certainly are some, but don't do it. You can also call method copy return type, which returns basically a character string that defines the type that a particular method returns. And we'll see that in a header in a second. There's a bunch of, it's basically defined. There's one character that represents a particular return type, and we can take a look at that. Actually, let's get right into it. Close up our test thing here. All right, so I've already defined my objc playground app delegate here, and pretty much all my code is going to be written in here. So I've got my application did finish launching, and the first thing we're going to do is list all UI colors. So what we're trying to do is basically take a look at the UI color class and look through its list of methods that it knows how to respond to, or list of selectors it knows how to respond to, method list, and basically print out all the ones that look like they might return a UI color. So we'll take a look at our list all UI colors method. The first thing we're going to do is call that class copy method list function. There's also this one which we hadn't really talked about. The class that you pass the class copy method list is not the class that you get back from UI color class. You actually have to call this object get class function on it first. Then the thing that you get back from that you can pass to class copy method list. And we're going to get back that malloc array of methods, and we'll get back a count, which will be thrown into this unsigned int variable here that we've defined. And we'll iterate over all of them, but we want to make sure that since we're actually copying the method list, it's memory that we own. It returns a malloc piece of memory that we own, so we have to call free on it when we're done. So if we got something back, we'll free it when we're done. So we're going to iterate over all those methods. The first thing we'll do is, oops, this is wrong. Let's get rid of that. I changed this earlier, but apparently I changed it on the wrong computer. NS string, oops, NS selector from string. Nope, wrong way. NS string from selector. All right, so we've got our methods. We'll get the ith one out of there. And then we'll call method getName on the method that we got out. And that's going to return a selector. But we want to print this thing as a string. The thing that I just replaced was as an implementation detail right now is that a selector happens to be a string. It happens to also be a C string. Not really something you want to rely on. It is an implementation detail, and although probably won't right now, is certainly possible that it can change in the future. So there's a function defined that does that conversion for you. So you call ns string from selector and pass in the selector, and you'll get back an NS string. So in that case, we've got the method name string. We'll check to see if that string had the suffix color, because UI color defines a bunch of methods like red color, black color, gray color. All the ones that return, the convenience methods for returning colors end in color, so we'll look for that. And then we also want to check to see if it returns an object. So we'll call method getReturnType on the method, and we've got an out value here that is a single character. And this method getReturnType takes 3 parameters. It takes the method that we want to know about, a pointer to a character array for which it's going to fill in the return type, and then the length of the array that it can fill in. Some more complicated things can have larger than 1 character return types. So in our case, we only care about ones that are a single character, so we can just use a single character and pass 1. To see if it returns an object, we can check to see if that return type is equal to this CID constant. Now this is what I said we were going to take a look at in runtime.h. CID, the return type, basically the character that defines that a class returns an ID is the @ sign. There's a whole bunch of them here. As I was mentioning, there's one for classes, one for selectors, characters, unsigned characters, shorts, unsigned shorts, ints. It's a lot like C++ in that sense. There's characters that define what the methods return, and then some of the ones that can end up being combining other things are things that return arrays or unions or structs. But for our case, we only care about the one that returns the @ sign, so that's returning an ID. So we'll check specifically for that, and if it does return an object, we're going to nslog that it's a class method that return on UI color, and we've got percent. How do we do this? %@ the method name string. So if we build it and run it, we're not going to see all this junk coming out. We've got UI color, black color, gray color, light gray color, white color, gray, all these different things. There's even some that aren't then defined in headers. So this is where you really, what not to do, or what not to do and how to do it. Oops, dropping stuff on the floor. The ones that aren't defined in headers, you can find out about, but you really don't want to call them. And we'll get into why later. But if it's not defined in the header, it's not public API, and it's not intended for use, by applications outside of UIKit. We've also got this interesting one at the top called Stanford color. That's probably not part of UIKit. So where'd that come from? So we actually defined at the top of this file a category on UI color called CS193p additions, and had defined the Stanford color method on there. So it's kind of proof that the runtime has actually taken this category and added it as part of the UI color class itself using some of these methods. So then when we went back and asked about it, it actually found this method as well. All right, so that's basically how you can take a look at things that are already in existence on classes that you already know about. So now that you've found out what some of these methods are, you may at some point think, hey, maybe I should change what one of those things does. If you've thought about that, and one of the things that you're thinking about changing is a UIKit or other framework-provided class, you should stop there and not continue on. But if you are thinking about changing the behavior or implementation of one of your own methods, it's something that you've got full control over all the source code for, and you're the only guy working on it, and you know how it all works, then maybe this can be interesting for certain use cases. Just be careful when you start talking about doing it with framework code. We've seen plenty of applications that have tried to swap out and change functionality on UIKit classes, even with changing functionality of undocumented functions and methods. The first thing that happens when we release a new operating system update is all those apps break because we've changed the way some internal method is implemented, or maybe even removed an internal method entirely, and they were trying to swap out the functionality on it, so the method's not there, the app starts crashing. So be careful with this stuff. But basically, you can add methods to existing classes. This is not interesting probably in and of itself because it's effectively the same as defining a category on a class. In fact, defining a category on the class is just a public way to get the runtime to call this for you. But class add method is basically what you would do in order to add a new method to a class. And you have to provide the class you want to add it to, the selector name that you want to add for, and the imp, which is, as I said, kind of that function pointer-like thing that would actually get called to execute this. And finally, the types, which would be the types that Actually, I'm not sure if that's the types it takes or returns. Seems like it must be both. I'm actually not sure. I have to look that up. You can also replace the implementation for an existing method. This is the part where you really don't want to do this to UIKit classes or other framework classes. Basically, you can call method set implementation, which given a method like we got back from that class get methods function, you can pass a new imp to basically replace what will get called when someone sends that method, or sends that message rather. And a common thing to do actually, for some definition of common, a common as far as these uncommon things to do go, is to actually swizzle the implementation of two methods. So if you have two methods defined on your class, you can actually swap the imps for each of them so that calling one actually executes the other and vice versa. So in that case, we can call method exchange implementations given two methods, and it'll swap their imps. So let's, well, right. So the reason you might want to do that actually is the public way to extend classes is using categories. And categories, we'll call that first method that we saw, which will add a new method to an existing class. But within a category, you can't ever actually call the original method. So if you're trying to use a category to augment behavior on an existing class, you actually can't, at least not without using runtime trickery. So let's say we have an existing, let's say we've got NS string, uppercase string, and we actually want to extend the behavior of uppercase string, but keep the original behavior of it having actually uppercasing the string. If we defined a category on NS string that defined uppercase string as a method, it would just replace the behavior from NS string. There'd be actually no way to call the original one. It would really just replace it. So we can use method swizzling as a way to augment behavior of an existing method. We can basically swap the imps of two different methods on a class, and well, it's kind of hard to explain. We'll see it in just a second. Basically, we can insert our own in there and basically get the functionality from both our extended method and the original one. It's kind of the same thing that you would get from subclassing, but without actually having to subclass. You can do it on an existing class. So yeah, I mean, you can't call super because a category isn't a subclass. A category is an extension to an existing class. So the superclass would be whatever its superclass actually was. It wouldn't call the method that you were replacing. So yeah, you might want to define this new method and swizzle it into place. Basically, you would call this method exchange implementations on the two methods that you're interested in replacing. We've got a lot of fire here because that's what you're playing with. And oh yeah, well, before we take a look at the code, it's a little weird, right? So let's say our fancy new method is the thing that we want to swizzle in place of uppercase string. If we want to actually call the original uppercase string method from this, we actually call self fancy new method. Now, just looking at it, it probably seems like, hey, that's going to obviously be an infinite loop and call itself forever. The reason it's not is because this method exchange implementations is going to swap the imp from uppercase string with the imp from fancy new method. So when other existing code calls uppercase string, what will actually end up running is our method here. And when we call fancy new method, what will actually end up running is the original uppercase string code, because we've actually swapped out their implementation methods. It's a little weird, but let's take a look, and it'll be hopefully a little easier to understand. So I've got one more thing already defined, an application did finish launching, and that's this swizzle string methods method here. So the first thing we'll do is call class get instance method on the NS string class, and we'll get it the uppercase string selector. That's the one that we're going to try and replace. And then we'll call it again, class get instance method, again on NS string, but this time using the selector obnoxious string. So I've defined obnoxious string up here, and we'll see that in a minute. But basically, that's a method I've defined in my own category on NS string. And then we'll call method exchange implementations for those two methods we just got. So we'll swap out the implementation of uppercase string with the implementation of obnoxious string. And then basically, we're just going to call uppercase string on some string and see what we get back. So let's take a look quickly here before we run it at the implementation of obnoxious string. So this is basically now, this is the method that's going to get called anytime any other code tries to call uppercase string. So the first thing we'll do is call self-obnoxious string. Now we've just swizzled out the method, so that will actually call the implementation from the old uppercase string. So at that point, we've got a string that is the result of having called uppercase string, the original implementation of it, on the input. We'll prepend some awesome stuff to the beginning, add some stuff to the end, And now we've got a much better uppercase string than we actually had started out with. And anyone who was using uppercase string gets this fancy new behavior, so it's pretty nice. So if we now just run that, now, well, we've got hello world here. All we actually did was we got the string hello world and tried to uppercase it, but we've done one better, right? I mean, it's so much better than the original. So probably you want to ship that as part of the OS, I would think, but yeah. Careful if you're replacing system methods. Yeah. I'm sorry?
Is this a permanent replacement?
So the question is it a permanent replacement? It's a replacement for the lifetime of the application that's running. I mean, it won't affect anything else on the system. It won't affect anything that launches later. But it will affect all the code running in your application, including system code. So anyone, any system code that was trying to uppercase strings is now going to be laughing at you and typing ones badly.
Even if you're using like some sort of a library that relies on uppercase string and you override it, you're just going to break your library that you're using.
Yeah, that's even if you're using a library that uses uppercase string, you're breaking that library. I mean, that's why you only really want to do this on classes that you control. Classes that you define in your app, it's somewhat safer to do because you control the entirety of it. It's still a little weird. I mean, if you control it yourself, why do you have to do this? But it's what not to do and how to do it. Yeah, it can be very dangerous because you're replacing the behavior of code that other applications are going to be running. Which reminds me, why is this dangerous? You're going to be replacing the code that other applications are going to be running. Or sorry, not other applications, other frameworks. The other code may be very dependent on the original behavior. Most likely, whoever wrote some other framework you're using did not expect you to insert lol before their uppercase string. So they may not deal with that very well. It very well may be code that you didn't write. So yeah, it can cause very unexpected behavior, very bizarre bugs, and certainly crashes. As I mentioned, we've actually seen apps doing this on the App Store, and we're more careful about that these days. But a lot of them broke. Pretty much, people were trying to swap out implementations of internal methods on UI table view that weren't even in a header. They weren't defined anywhere. We never even acknowledged they were part of the framework. Someone found them with class get method list and said, hey, I might want that to do something else, without really knowing what it was that it did in the first place, and swapped it out for their own implementation of something. And then when we changed it in iPhone OS 3.0, everyone who was doing that just stopped working. So it's not a good idea to do this to UIKit or system-provided classes. It's a lot of fun, definitely, but not so much fun when you have to figure out why it broke. So yeah, really, don't ship any apps that swizzle methods on system classes. It's cool to know, it's fun to play with, it's an interesting hacky kind of way to feel like you're messing with the runtime, which certainly you are, but do it with your own classes, don't do it with ours. So the Objective-C 2.0 runtime reference, which includes information about all this stuff, is at developer.apple.com and all that junk up there. You can go check that out, and there's, open up the headers. There's a bunch of other things that you can do as well. There's a lot. You can basically change anything about the Objective-C runtime that you might want to change. There's also a program that you can find out on, fun places in the internet called ClassDump, which does a lot of this for you. It basically calls all these internal Objective-C methods on, well, actually, it doesn't even have to call these. It actually parses the load commands. But basically, it figures out all of the classes and all of the methods and everything that are defined on objects in a particular framework and dumps them all out for you to look at. It's the way that a lot of these sites that are publishing information about unpublished APIs find out about them. You run this class dump, and it basically inspects all the classes and methods of in an entire binary and tells you about all of them. It has limited information in that it doesn't know argument names for like the values of the arguments, but since the names of the arguments are kind of encoded in selectors themselves, you kind of have a pretty reasonable idea of what things are intended to be. So it's unfortunately quite easy to find out a lot of stuff that can very easily burn you. Another thing to be very careful with. It's very interesting, definitely, to see how applications are written. I mean, you'll learn all about the internal implementation details of classes you never knew anything about. You can dump UIKit and you'll know all of the functions and methods that are used internally to implement UI table view. They're all there. You can see them all. Don't swizzle them out and try and replace your own bits of behavior, especially ones you didn't write. Yeah, as with the other thing, it can very easily be used for purposes that will cause things to be broken. It's fun to play with, not fun to ship code using this. So yeah. A lot of people, and I've seen this a lot on the internet when people are justifying their use of private APIs and things that aren't published. They're like, calling unpublished APIs is just like jaywalking. It's a minor offense, no problem. It's really more like jaywalking like across 280. You're going to get hit by a car. Yeah. It's the reason that they're not published, and some of us talked about this a bit after class a couple weeks ago. There's a lot of reasons, and it's not just because we're trying to be jerks and saying we've got cool stuff that you can't have. Framework APIs are kept private because they're not done yet, right? Maybe there's something we're still working on. We're not sure that its functionality we want to support forever. One of the things about APIs that get published in headers is that it's a commitment. I mean, we're saying that we are supporting this behavior. We try, once something's been published, to not break it to the best of our ability. So that it's not in a header yet is an indication that we're not yet sure that it's something that we really want to commit to supporting for a long time. And if you start calling it, we haven't committed to supporting it. We very well may remove it, change it, change its behavior, delete it entirely. And in fact, a lot of them will probably change. Some of them may never become public. They may just go away. It's not just because we're trying to hide stuff. We're not quite that big of jerks where like we've got the coolest thing and we're not sharing it with anyone. Sometimes, but not always. If your app depends on private APIs that go away, the best case is that it's just going to stop working correctly. More likely is that your app's going to crash, especially if you're calling a method that we just remove. Don't do it. The next software update is going to break your app. All right, so that's kind of the random tangent, what not to do and how to do it kind of section. So let's move on to something slightly more interesting and useful, I'd say, which is localization. Yeah?
Could you write unit test cases to make sure you're not calling any functions that don't exist anymore?
Can you write test cases to verify you're not calling functions that don't exist? Sure. But that's not going to help you with code that you've already shipped on the App Store that's broken for customers that already bought it. They're going to blame you when your app starts crashing all the time. All right, so localization, right? You've got your app, and you've written it, you put it up in the App Store, and you're selling a whole ton of them. But so far, you either are only selling it in the US, or everyone else is very confused by it and can't read or understand what it says. So we want to make it extend our audience and get everyone around the world to be able to download our app and actually read it and understand what's going on. So you want multiple languages and locales, but you don't want to have to build and maintain lots of different separate copies. You really want to just do this with one binary, one build that you can submit once and be done. So to accomplish that, we keep our localized resources separate from everything else. And localized resources includes things like strings, which need to be written in new languages, images that may have text, so they may need to be changed, or may have different product names for different countries. User interfaces and nibs. One of the particularly difficult things with some of this is languages that have very, very different lengths for similar text. I'd say German tends to land you in a lot of trouble. In English, you've got your button that says OK, and it's like 2 letters. In German, it's like 19 characters long and takes up 2 screens. So you can define your user interface in separate nibs so that it can be laid out to accommodate this. It's pretty nice. So where do they go, right? You've got your app wrapper. It's myapp.app. I'm not sure. Have you guys seen this, the wrapper concept? Have we kind of talked about it? Did we hide it? No? Well, OK, so every app is actually a folder, right? It's got a little bit on it that marks it as a bundle. So when you look at it in the Finder or, in the Finder, you actually see it as an application, not a folder. But it's actually a folder. It contains your myapp binary. And normally it will contain your nibs and your string and your strings and your PNGs. But if you've got localized content, you can actually have extra subdirectories under there that end in .lproj. And each one of those can include localized content for a different locale. So in this case, we've got an English one and a Japanese one. And we've got separate strings and a separate nib for each of those. So the strings will include a list of strings that need to be written differently in different languages. And the nib obviously is just different for the other language, possibly relayed out a bit. So there's really two steps to this. The first is internationalization. And this is usually the kind of step that'll be done by the programmer while you're doing development. Basically, you prepare your application to be localized. You'll set it up so that your nibs can be in separate lprojes, and you'll set it up so that your strings are loaded out of these strings files. Basically, you'll make it such that you can pass off the nibs and the strings files to a localization team, or yourself if you're multilingual, and actually have them change the strings and change the nibs to work with whatever language you're trying to support. And so that's the second step, localization, where you actually add the data that's specific for the different languages and locales. NSString provides a lot of support for this, which is great for the strings files. Basically, it knows how to deal with all the different text encodings that you might have to know about for different parts of the world. It saves you from having to deal with all the complexities of text and converting from one encoding to another. You basically tell it what encoding you're getting data in at, and it'll do whatever conversion is necessary to draw it on screen and save it off. So when you're reading data off disk, you'll probably use something like init with data encoding, where you've got an NSString encoding. And different sources of data will usually define what encoding their data is in. Like some of the Twitter and Flickr APIs probably define that their strings are UTF-8 or UTF-16, usually UTF-8 for that kind of thing. So you would pass the NS UTF-8 string encoding when you're getting the data, and basically NSString knows how to parse that and then convert it to whatever encoding it needs. For your localized strings files, you'll usually, you'll have these files that map from a string that you'll have in your code to whatever the string is that'll be displayed at runtime to the user. Basically, the unlocalized key, which is usually the same text as whatever the string is, but in your original language. And then the value for that key will be the localized version of that string. They're stored in strings files as key value pairs. And usually they're, I guess, UTF-16 for the encoding, although I'm not sure that that's actually a requirement. So an example of what one of these is going to look like, let's say we've got an English and a French lproj, and we've got a strings file called greetings.strings. So in our English one, in the original, basically the key and value are going to be the same, right? The key is, in the first case, hello, and the value is hello. And in the second one, we've got welcome to @. So this is a case where we've actually got a format string. So we're going to be at runtime inserting some other string in there. And then we've got blah at, and in every case, the key and value are the same. When we go to convert those to French, obviously we can just translate the hello. In the second case, for welcome to, we can just translate that as well. Now, in the third case, and you may find in other languages you actually have this problem more often than not, we're actually inserting two different strings into that format string there. But let's say that in French, we actually have to swap these. Maybe the noun and verb actually go after, in the other order. So you can specify in your format string here that the second argument should be used first, and the first argument should be used second in this case. So this is probably more a problem for whoever's localizing your app than for you, unless you're doing the localization yourself. But you can specify those kinds of things. In your code itself, since now you're actually trying to load localized strings out of your bundle, you'll use one of these two functions to get your strings rather than actually hard coding them. So you'll call nslocalizeString, and the first thing you'll pass in is the key that's from that dictionary we were just looking at. And the second thing is basically a description of what it is that this string is supposed to represent, so that when your localizers are coming along and figuring out what to translate this to, they've got a slightly longer description of what it is that this string is going to be used for. So in this case, our string is hello, but we're going to tell our localizers it's the greeting for the welcome screen, so they know what it is that they're actually trying to translate. Give a little context rather than just a single word. And then in the second case, we can specify a particular strings table. So on this slide here, we just saw we had greetings.strings that's the name of our table, basically. You can have multiple strings files that have different names, and you'll specify the name as the table, and it'll know to look it up in that particular file. But otherwise, it's the same. Hello is the key, and a little extra descriptive text about what it is. There's a tool called genstrings that ships as part of the SDK. And this basically scans through all of your source code and finds any places where you're using NS-localized string or NS-localized string from table and builds that strings file for you so that you can not have to generate it manually. When you're writing a constant string into your source file that you know you're going to end up localizing, just write it using NS-localized string and put the key value in there. And then after you're done, you can run genstrings to get that whole strings file and pass that off to be localized. It inserts those comments that you saw in the NS-localized string method into the strings file as a hint to your localizers, so they know what it is that all the strings are going to be used for. And yeah, you run the tool over all your .m's, and it grabs all your strings out and puts them in one place so that they can all be localized at once. So if you've got other resources that need to be localized, like images or nibs is a special case because nib loading already does this for you. But NSBundle knows how to do this for you. So if you're getting a PNG from NSBundle, it'll know to get a localized one if you need the localized one. So they automatically will use the one that's best for the localization that you're currently using. Internationalizing nibs, as I mentioned, it's good idea to have a separate nib sometimes if long strings cause layout. Probably better to be avoided if you can, because if you do it, it means that you actually have to keep them all in sync. If you change your English nib to add some new button, you're going to have to go through all the other localized nibs and actually add that button there as well. And so it adds a lot of extra work to your development. So if all your languages have strings that all kind of fit within the nibs without actually changing the sizes of interface elements, having just one is definitely more convenient. But that's not always possible. German, as I said, it'll get you every time. When you want to write ice skating, it gets kind of long. I don't know why I always use that. Somebody once told me, I don't even know if it's true, that it was slippery shoe dancing is effectively the literal translation. Anyway, so if you had your nib and you wanted to localize it, you can go ahead and get info on it in Xcode. So in this case, we're getting info on mainwindow.xib. And down at the bottom there, we've got a make file localizable button. You can click that, and it'll basically split it out into English and French there for you so that you can just go ahead and localize your nib right away. So some of the other things that you might have to keep in mind when doing localizations are provided by NSLocale. Some of the interesting things are measurements, currency, number formatting, date and calendar formats, country information. Different countries have different ways of specifying some of these things. And NSLocale provides a whole bunch of different utility methods that you can use to deal with some of these things. Some of the other relevant classes also do something similar, like NSDate has some utility for this kind of thing as well. So yeah, that's basically the gist of that. Any questions before we kind of get onto a quick jump through a bunch of random small? Okay, so we get obviously some email from time to time with random questions, and certainly there are a lot of frequently asked questions that I hear a lot. So just let's go over a few things that are pretty commonly asked, I guess. First off, a lot of people ask, and I guess this is starting to be more commonly known now, but still a question I see pretty frequently. How do I launch my app in landscape? When you just create your new Xcode project and start running it, it always launches in portrait, even in the sim, no matter what you do, even on the device, it's always going to launch in portrait, no matter what you do, right? Well, how do we prevent that? So there's actually two steps to doing this. The first is you have to change a key in your info plist. So you'll specify an initial interface orientation in your info plist, and it basically looks like that. You've got your initial interface orientation, and you can pick any of the 4 standard orientations: landscape left, landscape right, portrait or portrait upside down. And doing that will cause it to launch in that orientation. But once you've launched, you then also have to specify that your application supports that interface orientation, or the first thing that's going to happen is it's just going to jump back to the other. Well, oops. I already showed it, so ruins my chance for that. I was going to ask if anyone remembered what the method was, but you want to override should auto-rotate to interface orientation and make sure you're returning yes for whatever it is that you've specified as your launch orientation, or else it's not actually going to launch to that orientation. If you can, you probably want to return yes just for the things that you actually want to support. Most of the system-provided applications will not rotate to portrait upside down. They'll rotate to portrait, landscape left, landscape right, but not upside down. That's a pretty common behavior, I'd say. Most applications behave that way. Obviously you can pick what works best for your application. Some applications will pick just both of the two landscape orientations and not support either of the portrait ones. I think you'll find probably games more than utility applications will tend to do that. Pick the ones that are right for you and specify your default launch. This works in iPhone OS 2.1 and later, so basically everyone who you're interested in sending your app to is going to be using a phone that can do this. Somebody who hasn't updated past 2.0 will not be able to take advantage of this, but really how many of those are left at this point? And if you're out there, update. So you're going to launch to something like this, right? So let's take a quick look. Not too much to it. We already pretty much went over everything. But let's take a look real quick in our resources. We've got our landscape info plist. This is just the info plist. My project is called Landscape, which is why it's Landscape info plist. And what I've got right at the top is initial interface orientation, and I've picked Landscape right home button. There's these other ones that you could have picked, portrait bottom home button, portrait top home, portrait left, and portrait right. Those are the UI interface orientation, landscape left, landscape right, portrait, and portrait upside down. So I've already specified that we want to launch in, sorry, what did I say? Right home button, landscape right home button. And in my view controller, I've already implemented should auto-rotate to interface orientation. Well, actually, let's get rid of that for a second and just say yes. So if we build and run now, we're going to come up and launch starting out in landscape already. And if we rotate, it'll rotate because I've said yes to everything. We can even go upside down, although the simulator actually doesn't let you do that. But we've kind of got a problem here because in portrait, this really doesn't make any sense, right? We haven't even done anything to make it lay out in portrait. We're just clipping half of our views. So we really don't want that. We can instead change that to, oops, let's go here. UI interface orientation is landscape. That's a macro defined in UI application.h, and basically just returns yes if the orientation is landscape left or landscape right. So by doing that, we instead say we only support the two landscape orientations. So then even if we rotate to portrait, it's not going to rotate. It'll just stay there. But when we go to portrait, or to the other landscape, it'll flip around. So not too much new there. You've probably seen a lot of that before. All right, so another common question is, how can I customize UIKit views? Oh, yeah.
So if my app has a tab bar controller and this tab has another view controller, do I have to override what rotate function
Right.
for tab bar controller and view controller?
So the question is, if you have a tab bar controller and you've got other view controllers in there, what do you have to do to get it to rotate? With tab bar controller will basically ask all of the view controllers in the tab bar if they support a particular orientation that you're trying to rotate to. And if any of them says no, it will not rotate. There's basically no defined transition for tabbing between view controllers in different orientations. So basically, if you want to support an orientation in your tab bar controller using app, all the view controllers in your tab bar controller have to support all the orientations that you want to support, or else it won't rotate. Not including tab bar. You don't have to subclass UI tab bar controller. If you want to support rotation with a tab bar controller, basically tab bar controller's implementation of the rotation method calls all of its children and checks to see if they rotate. And if all of them do, then it says yes itself. Otherwise, it'll say no. Yeah, subclassing tab bar controller to do auto rotation is both not necessary and not recommended. Do it in your subclasses of view controller that are in the tab bar. Right, so common question is, how do I customize UIKit views and controls, right? So I've got this, UI table view. How do I make it look like something really cool? I've got a UI picker view. How do I make it look really cool? Some of those, the answer is, it's easy. Some of those, the answer is, don't do that. There's kind of a line, and we'll take a look here. So some of the classes are definitely designed to be totally customizable, right? UI button, UI table view. These classes have methods defined on them for customization. They're not really even intended to be used as is. They're just intended to be customized. UI button has a way to set a background image, a way to set different colors. Table view, it's totally customizable. You provide the table view cells, and you can customize those however you want. Some of the classes have pretty limited customizability. UI navigation bar, for instance, has a whole subtree underneath itself, but none of the views in that subtree are documented. Consequently, none of the views in that subtree are intended to be used or touched or changed by any of UI navigation bar's clients. The basic overriding idea here is that if a view's subviews are not publicly documented in any header or documentation, they're not intended to be used. And very often we've actually found apps have broken because of reasons like this. Basically, an application will get a UI navigation bar and say, I want to change the way the back button looks by reaching in there and replacing something in it. So they'll call like UI navigation bar subviews, say, oh, well, it's in this object at index 1, so subviews object at index 5. And then in the next version of iPhone OS, when there's some new subviewer in there, or we've removed something or changed something about how it's implemented, those applications just break because the index that they're looking at is wrong, and some subview has changed its class. It's very easy to break that way. So don't go groping through the subview hierarchy looking for things to customize. It looks like we're pretty much out of time. So basically, it's pretty much safe to customize anything that has methods defined in the header specifically for customization, but don't go looking through the view hierarchy for things that don't. I think actually we'll pretty much stop there. I had a couple other things, but nothing we can't skip. So thanks.
For more, please visit us at stanford.edu.